Hey everyone, we're going to start today with a quick example program to precede your turtle race assignment that's currently on REPL. What we're going to do is we're going to create a program in which a turtle is going to randomly move around on your screen, different directions, different distances maybe, until it gets to the edge of your screen, at which time the program is going to stop. Now, one of the things that I want you to remember about REPL is the canvas is really, really big. And if we tried to make a curved turtle go until it was actually at the edge of the canvas, it would probably not be on the screen and not easy to see. So what we're going to do is we're going to take care of that actually as the first thing that we do after, of course, importing turtle and random. All right, so if I want to change the size of my window, which is something that we definitely want to do here, I'm going to do that by first setting up my screen. Now, our screen is going to have a name, just like our turtles are going to have a name. Our screen in this program is going to be called WN, kind of standing for window. And what I want to do is actually set up my window to be a certain size. I'm going to go with 600 by 600. Now, the normal REPL size is 2000 by 2000. That's a little bit crazy. This 600 by 600 is basically the total width of your screen, 600, and the total height of your screen, 600, which means that if you think about that broken down, our x coordinate goes from negative 300 to 300, our y coordinate goes from negative 300 to 300. All right, so our screen's set up. Maybe we'll do something like wn.bg color, light blue, something easy to see, and we'll run it. Let's see. So there it is. Notice 500 or 600 pixels isn't quite at the edge of my screen on my laptop here, but it just about makes it to the bottom. So it's a pretty good starting point. Obviously, I could adjust it if I wanted to, but and again, notice I can't scroll. There's no scroll bar available for me to actually use on either side. So we'll at the window to be like this. Now, the next thing we're going to do is make our turtle. So t equals turtle dot turtle with a capital T. Again, what this allows me to do is have multiple turtles. Maybe I wanted two turtles, for example. I'll say T1 is the first one, and then we'll go T2 equals turtle dot turtle, and I'd be able to have two different turtles on my screen. All right, I can do this as many times as I want, actually. But the one thing I'm going to remind you of is if you have more than one turtle, they don't actually move at the same time. All right, in programming, each line of code is one after the other after the other. So we'll have to think about that as you do your Python turtle race program. Anyway, so one turtle is enough for now. Let's go back to just T and think about what actually has to happen here. Right, so again, we're going to have a while loop because we want to allow this turtle to move until it doesn't have to move anymore. And we don't know exactly how many times that's going to be. As far as the condition from my while loop, I'm going to just have a temporary comment filler right here. I'm going to say the turtle is in the screen, or I guess on the screen is a better way to say that. And of course, that's not a completed while statement, but that's a good starting point. That's going to help me with the rest of this program. Now, what we're going to do each time we move a turtle is we're going to say, okay, well, let's move forward by a certain amount. How about we do random dot rand int between 3 and 10 steps. So we'll move between 3 and 10 steps every single time. And then we're also going to turn, maybe left, random dot rand int 1 to 360. And what's going to happen now is this turtle is going to move a little bit, turn a little bit, move a little bit, turn a little bit, and it's going to turn between 1 and 360 degrees, which means it could go backwards, it could go to left, it could not turn at all. To demonstrate this, let's just make this a while true, even though that's not what our final while loop is going to say, and I'll show you. So there it is. It's turning a little bit, it's moving a little bit, and it's going way too slow. Way too slow for me. So let's do this first. Let's say t.speed 0. We'll stop this and run it again, see how that's doing. Much better. as fast as I would like? Maybe not. It kind of takes a long time for it to move when it can go backwards. Let's speed it up even more. How about we adjust the tracer? Remember, tracer is something we can use to speed up animation even more than just the turtle speed. Previously, we've turned off animation completely. I'm going to be a little more specific this time. Tracer, we're going to actually attach to the window. And there's two things that go inside the parameter list for tracer. The first is how many animation frames that we draw, or really technically how often we skip. Now, if I leave the first thing as the first parameter is 0, we're going to skip everything. All right. If I have it as 1, we're going to draw everything. If I increase it to 2, we're going to draw every other. If I go 3, we're going to draw every third. If I go every 4, sorry, if I change it to 4, we draw every fourth frame, and so on and so on. The second parameter is the delay between drawings. So what you're going to notice here is if I draw every frame with no delay, it looks like this. Pretty much the same as it did before. Maybe before it had a slight delay, now it doesn't anymore. If I want to do something like every 5th frame, now it's faster. Considerably faster, probably 5 times faster actually. And that's a pretty good starting point. Notice the turtle's still moving around. If I let this go forever, potentially it never reaches the end, but chances are it probably does eventually, and it did. But it's still going because we never finished our while loop. So let's stop the program and let's finish it. If I want to know when my turtle's at the edge of the screen, we could either use the screen size that we created over here, or we could actually ask Python to figure out what the width and the height of the screen actually are for us. All right, and we're going to do that somewhere to compare to actually the turtle's coordinates and decide when it's time to actually end this program. And for me, I would love to be able to do that with a function that returns true if the turtle's on the screen and false if the turtle's not on the screen. So I'm going to name that function without actually creating it yet, is on screen. Now this function, again, that's not created yet, is going to need 2 different parameters. It's going to need to know where the turtle is, and it's going to need to know what the screen is. All right, so I'm going to include those in the parameter list. And again, my program's not going to do anything yet because I haven't created that function, so let's define it. Is on screen. Again, with the turtle and the window. This function, like I said, is going to decide if the turtle is on the screen and return true, or not on the screen and return false. We can do that with an if statement, of course. We can actually also do a little shortcut with the return statement, and maybe I'll come back to that later on. But the first thing we're going to do, even though we technically already know the width of the screen, is I'm going to make a variable representing the maximum x coordinate and the maximum y coordinate. So let's call it x max and y max. Now, x max is actually going to be whatever our total screen width is divided by 2. And if you think about that, again, my screen happens to be 600 pixels across, right? And width-wise, 600 pixels. But remember, the middle is 0. So that means 300 to get to the end, which means my x max is going to be 300, or technically, wn dot window width divided by 2. And my y max equals wn dot window height divided by 2 for the same reason. Now I'm going to run that because I'm just checking for errors, and thankfully I have no errors here, so that's good. Our program is done because there's nothing actually there. But what we'll do then is we'll say if t.xcore is less than x max and t.ycore is less than y max, return true. Oops, capital T. True. No, true. Why does it not like that? Okay, return true. Better, much better. Else, return false. Right. Now, I hope you're looking at that and you're saying, hey, wait a second. That only checks for the maximum x and the maximum y, but not the minimum x and the minimum y. So I check the top and the right, but not the left and the bottom. And we're going to actually do a little trick here to not have to use those other two statements. I'm going to actually get the absolute value of the x coordinate. And I'm going to get the absolute value of the y coordinate. So that way, if I'm near the bottom border, the bottom boundary, I'm a large negative number. For example, in my program, close to negative 300. If I get to negative 301 and take its absolute value, it would be positive 301, which is no longer less than the x max or the y max, and would actually cause my if statement to evaluate to false and therefore return false. Okay, so my function is actually done now. This function is on screen, is going to return true if we're on the screen and false if we're off the screen. And we can run it and see. So here we go, moving pretty fast. Again, technically, random numbers could say this is going to stay in the middle of the screen forever and just make a cool pattern until everything turns all the way black. But chances are we'll eventually leave the border. What I expect to see is we get to the edge of the blue and we stop moving altogether. But of course, I'll have to sit here and watch this with you until it gets to that point. Getting further away from the edge. At the very least, we get some pretty cool abstract art. And every time it gets close, we're right back to the middle. What do you see in that shape? What does it look like to you? We're done. All right, notice the program stops. We got to the edge, program stops completely, and that's the end. That's our example. All right, so this is a pretty good starting point for your turtle race. Of course, I gave you different starter code to use for your turtle race, but I hope that after watching this video, you understand some different parts of maybe how turtles can work and how this while loop could help us. Of course, on the turtle race, we actually drew a race course, so you're not going to have to worry too much about the width and the height of your window, but if you wanted to, you could do something similar to know when your turtle actually makes it to the finish line, or one of your 4 turtles makes it to the finish line. Anyway, that's it for now. Good luck on your turtle race assignment. Let me know if you have any questions. Otherwise, I will see you later.